Hello everyone, welcome to Terraform for Developers series. And baby, in this series, I'm going to take you from zero to confidently deploying and managing cloud infrastructure using infrastructure as code. Before we write a single line of Terraform though, I want to spend this first episode on the why. Because if you don't understand the problem Terraform is solving, it's hard to appreciate why it's worth learning. Here's a situation I'm sure you've been in before. You need to deploy something to AWS, maybe a Lambda function, an S3 bucket, or an IAM role. So you open the console and walk through the wizard and do everything. It may take an hour. You're done great. Now 3 months later, a colleague joins the team. They need to recreate the same setup for a test environment, and they have a bunch of questions for you. How did you configure the Lambda? What were the timeout settings? What versioning enabled in that S3 bucket? Even if you documented everything in a wiki, it's always one manual step away from being out of state. Or maybe you want to replicate the whole stack in a different region. In DevOps, we call these kinds of environments snowflake servers. Everyone is unique, handcrafted, and impossible to reproduce exactly. Infrastructure as code flips this on its head. Instead of clicking through a console, you write configuration files that describe your infrastructure. Those files live in version control, right alongside your application code. Anyone on the team can read them. Changes get reviewed in pull requests, and you can roll back if anything breaks. Think about it. We already treat application code this way. We don't paste code directly into production servers by hand. We write it, review it, test it, and deploy it. Same idea here, version control for your cloud. Code review for your networking, and automated deployments for your databases. That's what IAC gives you. There are several IAC tools out there, and it's worth understanding how Terraform fits in. AWS has CloudFormation. It's tightly integrated with AWS, but it only works on AWS. Azure has Bicep. Pulumi is interesting because it lets you write infrastructure in Python, TypeScript, or Go, which some developers love because it feels like normal code. Terraform, made by HashiCorp, takes a different approach. First, it's cloud agnostic. You can use the same tool and the same mental model whether you're deploying to AWS, Google Cloud, Azure, or third-party services like Datadog, GitHub, or Cloudflare. Terraform has a provider for almost everything. Second, Terraform has a massive community. There's a huge library for open source modules, tons of documentation, and it's used in production across companies of all sizes. Third, and this is the one that matters the most for your day-to-day work. Terraform gives you a consistent, readable workflow. You can plan before you apply, and no surprises. Terraform uses what's called a declarative approach to infrastructure. Instead of writing step-by-step instructions for how to create something, you describe the desired end state, and Terraform figures out how to get there. Compare that to an imperative approach, where you'd write, go to the IAM console, click Create Role, select Lambda as the trusted service, attach this policy. That's instructions. In Terraform, you just say, I want an IAM role with these properties. Terraform reads your configuration and checks your already existing your AWS account, figures out the difference, and then creates, updates, or deletes resources to match your desired state. Let me give you a preview of the project we're going to build throughout this series. We're going to work through a real-world Terraform project that demonstrates the pattern you will actually encounter at work. The project deploys a Python Lambda function to AWS. It creates a properly scoped IAM execution role with least privilege permissions. It sets up CloudWatch logging with a defined retention period. And it uses a remote state backend stored in an S3 bucket, which will bootstrap with its own Terraform configuration. That's it for episode 1. We covered the problem with manual infrastructure, what IAC is, and why it matters. In the next episode, we are going to open up the project and walk through how a Terraform project is structured, the files, the HCL syntax, and what goes where and why. If you find this useful, subscribe and don't miss the next one. I'll see you next time. Thank you.